derivatives with natural logarithms, chain rule, Leibniz notation. Okay, so with the derivatives with logarithms, you'll have a function, and inside, this is the natural logarithm, ln, which is basically log to the base e. So you have log n of x, and you wish to derive it. The derivative of such is 1 over x. There is a proof to how you get this, but basically that's the steps that we're going to take today. We're not going to do a proof, we're just going to use this rule. And so in a sense, everything in the brackets just becomes under. So it just, when you derive ln, say ln 2x, you would get 1 over 2x. ln x, you would get 1 over x. And so on. And just to recap on chain rule, when you have a function x within a function u, and then a function u within a function y, you use the chain rule as such. And if you have one extra, you have like x within v, v within u, and then u within x, u within y, you would use this. I've explained this in previous videos. If you don't understand the chain rule or this way of doing it, I would suggest watching them first, but stick around anyway if you want to. So let's start with example 1. Y equals ln 2x. So I said it before, but what this will be, this is the steps that you follow. So you make u, you start with the innermost function, we'll call it u. U will be equal to 2x, and then we'll make y equal to ln u, because we've replaced the 2x inside the brackets with a u, so now y becomes ln of u. So the formula, derivative of y with respect to u multiplied by the derivative of u with respect to x. So we need to find the derivative of u with respect to x and the derivative of y with respect to u. So the derivative of u is just 2, and the derivative of ln u is just 1 over u, because whatever's in the brackets just becomes the denominator. So if we fill this in, what we end up with is dy over du, which is 1 over u, multiplied by du over dx. du over dx is 2. Now if we bring the 2 on top because they're multiplying, and we sub in the u, what we get is 2x. So cancel out the 2's, and that equals 1 over x. So the first derivative of ln 2x is 1 over x. Okay, so another example. Let's say y equals ln x squared plus 3x plus 2. Start with the innermost function, u. We'll make that equal to x squared plus 3x plus 2. And y will be equal to, again, ln u. The equation is dy over dx equals dy with respect to du, and multiplied by the derivative of u with respect to x. That's a multiplication sign. Okay, so we need to find the derivative of u with respect to the x, and we need to find derivative of y with respect to the u. So the derivative of x squared is 2x, the derivative of 3x is 3, and the derivative of 2 is nothing. Well, 0. The derivative of ln u is just 1 over u, and so we can sub these values in. The derivative of y with respect to u is 1 over u, and the derivative of u with respect to x is just 2x plus 3. So, if we put the 2x plus 3 on top, and we sub in the u, what we end up with is as follows. Okay, so for another example, let's start with, we'll do an example with a function within a function within a function. So let's say y equals negative cosine ln x squared. I'll take you through how to do the derivative of negative cosine, but if you don't know how to do trigonometric derivatives, I would suggest watching the videos I've done on trigonometric derivatives. So we'll say, because we have a function within a function within a function, we'll be using the y equals u, u equals v, and v equals x. So the most inner function will be v. V will make equal to x squared. We'll make u equal to ln v, because that's the second innermost function, and v has been labelled as x squared. So, and y will be labelled as negative cosine of u. So, if we were to write out the derivative for the chain rule, it would be derivative of y with respect to u multiplied by the derivative of u with respect to v multiplied by the derivative of v with respect to x. So we need to find the derivative of v with respect to x, the derivative of u with respect to v, and the derivative of y with respect to u. The derivative of v with respect to x would be 2x. The derivative of u with respect to v would be 1 over v, because ln v, derivative of ln v is 1 over v. And the derivative of negative cosine of u is just sine of u, because sine goes to cosine, cosine goes to negative sine goes to negative cos, and negative cos goes to sine. It's just a cycle. So, if we were to sub these values in, dy over du, sine u, multiplied by du over dv, 1 over v, multiplied by dv over dx, 2x. So, if we were to rearrange this and sub in the values, we would end up with 2x, bring the 2x at the front, sine, sub in u is ln v, we'll sub in v, x squared, and then we'll put that on the top of this here, well, because we're multiplying it, so it'll become the top of the two, of the fraction, it'll become the numerator. So, and we'll sub in v is x squared, and that there is the first derivative of this function up here. Thanks for watching, I hope this helped.